Welcome back. I think I had to cut off that video because of some problem, and now I think it's fine. I'm continuing from where I left. The two body system, lower body force is applied, and then the length of the lower body is L. So we wanted to find out if the time taken for the upper body to fall of the lower body, and the second one is how much displacement this lower body undergoes, how much displacement the upper body undergoes. All that you can do it. And as far as A1 is concerned, from this you got it. How to get A2? So, simple. See, M2 A1 minus R is equal to M to L. AR is 0. What is the force acting on the upper body? There is only one force acting on the upper body, the horizontal. Likewise, right? And on the upper body, if you see, I have already explained it to you. This is F2K. So F2K is equal to M2A2. But F2K is mu 2 N2, and N2 is M2G. Therefore, A2 is equal to mu 2G. A2 is in the forward direction. A1 also is in the forward direction, but A2 is less than A1. Therefore, A2 minus A1 is in the negative backward direction, that is AR, we already did it. So, if they ask you S2, you have to simply say half A2 T square. That's it. It's as simple as this. This is with respect to ground. S1 with respect to ground. Yes, they may ask questions like this. S1 with respect to ground, S2 with respect to ground. Likewise, we have tried to work on this. Is that clear to you? Right. So, the first thing that we did on this is, if all the bodies, both the bodies are slipping, we took the case. Now we go with these special cases. Very, very important. Special cases. What do you mean by these special cases? Here. Let us start. First, I am applying 1 and 2. This is F. I am saying this is equal to KT. Right. When you start applying, suppose I am increasing my force with the time. Initially, I apply nothing, then 1 Newton, 2 Newtons, 3, 10, 20, 30, 40. At one stage, the whole system begins to move. Very important. As you increase your F, right, let F be KT. K is a constant. At T is equal to T1, system starts moving. The whole system starts moving. Likewise, suppose if I have a body like this, right, and I am applying initially, it won't move. Afterwards, if you see, this is how it moves. So, system as a whole. Suppose if I take with more force, then what will happen? This body then tends to slip. You get the point? So, first of all, at T is equal to D1, system starts moving. So, T less than T1. Then before that time, you are applying the force, but system is not moving. But there is a force, so that opposing force will develop here. So F1 will be F1 static. A T is less than T1. F1 is equal to, I want you to understand this notation very clearly, my dear friends. F1 means this one. F2 means this two. And F1 means static. So there is no slipping. So F1 is equal to F1 is. Fine. What about F2 now? Very interesting. And in fact, if I could be a direct class, I could have asked you the question. And then I would have got your answers. And I know I'll get some crazy answers, sometimes interestingly correct answers. And sometimes correct answers by mistake. All are possible. But then I can't give you time and all that here. But if you can think for a while, I've seen few videos giving a time on the other side. So 10, 9, 8, likewise, some sort of a countdown. Well, in the meantime, I've been speaking, therefore you could have tried. You see, when does friction occur between the two? When you make an attempt to displace the body. Now, I am not able to move the lower body. I am not able to move the lower body. So, where is the question of making an attempt on to move it? I hope you understand this point. You see, here is the body. Let me say, this is the body here. Okay, I am taking it here. Now I am trying to move it. You see, whether you move, you are not moving. Let us say at 100 newtons the system moves. I am applying 50 newtons. So it's not moving. Okay. Once there is no movement of the lower body, these two together is treated as a single body only. So there is no force acting on this body in the horizontal. Because there is no attempt to displace the body. When 50 newtons I apply, 0 newtons I apply, it makes no difference for the friction between the two bodies. I repeat, I want you to understand. I apply, let's say, at 100 newtons, this will start moving. Once it starts moving, I am making an attempt on this to take it forward. If I move very fast, then only it will come back. Okay? So 100 newtons, it will start moving. Less than 100, it doesn't move at all. If it doesn't move, there is no attempt on this to take it either way. Therefore, there is no friction because there is no attempt made. Got the point? Therefore, F2 is equal to 0. F1 is F1s. And what is that? At T is equal to T1. KT F1s. Suppose I plot, very important. I want to plot this. You see, we are getting into crucial aspects of this friction. Okay, I hope this is already written for you. I try to give like this. So master body, as you increase, let this be the time, let this be the friction. F1s is equal to KT. So it is directly proportional to T. Slope is K, whatever it is. This is static, 1 and 0. Two. What do you mean by that? There is no friction. Friction is 0 on the second body. Supposing this is T1. At T1, F1 is F1L. Okay? So, this is your limiting friction. First, lower body and the ground I am plotting. Lower body and the ground. How does the frictional force vary? Mu is constant here. I am not referring to that. Purposely I took this force to be a function of time. Instead of that, I could have told you, why don't you apply a variable force slowly increasing at a constant rate? That rate I have given only in terms of time, nothing else. Okay? So it is a straight line with the slope as k, no problem. Afterwards, you are expected to get some kink and then it should move like this. I am avoiding that kink here. What is going to happen when T is greater than T1? F1 is F1k. So this is all that will not change. All pertaining to body number 1. Right? Then, now look, you get an interesting feature. On the upper body, there is, because the moment it goes, A1 comes into play. So there is a pseudo force. And here you get F2, yes. T greater than T1, F1 is F1k, F2 is F2s, but at T is equal to T2, M2 starts slipping. At T is equal to T2, M2 starts slipping. M2 starts slipping. Okay, fine. So, when T is greater than T1 but less than T2. Greater than T1, this is F1 will be, that will not change hereafter. What about F2? F2 is equal to F2, yes. Now this is important, very important. What is its value? We will see. First of all, you say M2A1 is equal to F2AS. Okay? M2A1 is F2S, and then the lower body F minus F1K is equal to M1A1. One K, the moment it comes, I will put that here also for you. T greater than T1 but less than T2. F1K, F2S, F. So minus F2S is equal to M1A1. Previously, if you recall, when it was slipping, we put F2K because it was slipping. Relative motion was there. Now there is no relative motion, no relative acceleration. Therefore, you got like this. Okay? Fine. And the upper body is straight. Upper body I have just shown you, but again I will show you. And this is F2S. So F2S is M2A1. Or, since I am interested in F2S, A1 I will replace. F1K minus F2S is F2S, of course, M1. M1 is F2S by M2. Got this? Or F minus F1K is F2S plus 1 plus M1 by M2. This is equal to M1 plus M2 by M2. Alright? Got it. And I am interested in this. So, F M1 is mu1 N1. N1 we know that it is equal to M2 by M1 plus M2. This is F2S. A very complicated result if you see it carefully. F2S, this is a constant. If I rewrite this in a way we understand, F2S is Y is equal to M2 by M1. F is KT, M1 plus M2 and minus M1 plus M2 gets cancelled, mu1 into G. M2 into mu1 into G. That's what you are going to get out of. This is in the form Y is equal to AX plus C. There is a negative intercept which is equal to minus number 1. And when you plot it, what is the slope here? Slope is M2 by M1 plus M2 into K. They may give you the diagrams in the exam. Choose the right one. They may not ask you to do all, but you should have an idea. And unless you are able to write these equations on your own, you will not be able to do any of this analysis. Remember that. Never try to get it by heart. And whatever I have been giving is not meant for reproducing as it is, but you should be in a position to do it at every stage, remember. Now, the first F1, we got slope as K. What is the slope of F2 now? M2 by M1 plus M2 into K. If it is K, this is less than K. Do you agree? M2 numerator, denominator is more because M2 plus M1. So, less than K. So, when I drop from this point, this slope means it could have been like this, but it should be less than this. If I extend that, you are getting a negative intercept. They may ask anything in the exam. So, this value is mu1, mu2. I am going to erase this part so that it won't be confusing for you. Right. Okay? So, slope is less than this. I hope you got it. Now, this is 2, 2, 2, but static. Okay? Let me say this time is T2. That means when T is greater than T2, we have already done that before. We have already done that. What is F2K? Because this is F2S and this will be F2K. What is F2K? Mu2 M2G. And what is F, K or L? I am not distinguishing. F1 is okay. Remember, this is mu2 may be 0.1. I'm just saying mu1 may be 2 or 3 possible. This is much more. Or mu2 may be having a very high value. Mu1 is very less. Suppose G is common in both the things. When I'm dividing these two, this can be greater than 1 or less than 1, equal to 1, we do not know. So, in other words, this might go like this and same thing. Or it may go beyond this and also you can draw. All depends on the values. It is not necessary that this should be below this. Theoretically, it is possible. You have to take the appropriate values. You understood now? Now, let me give a glimpse of what I discussed in this example. First, what I took, the whole system of bodies, they were moving, etc. I have started giving. AR we found out, and F2K, F1K, all that. The next special case, what did I do? T equal to T1, system moves. Or A1 just begins. F1 is F1s, F2 is 0. I have given you ample explanation for this. This is T equal to T1. Next, A2 is 0, AR is 0. So, you derive some equations. You can directly substitute these values and you will get the same equation as I have derived in this case. Now, so T less than T1, this is the scenario, okay? Or T is equal to T1, F1 is F1L. F1L, F2 just begins. T is equal to T1. Less than T1, this remains 0, this is static, that's what I plotted. Remember, every time you get that equation, you got it as F is equal to KT, which is equal to F1S. So the slope there is K. We got it like that. Fine. Now, T is equal to T2. M2 starts slipping. Now, this is important. Till T2, system moves together. Till T2, system moves together. They may ask like that also. Okay, but T is less than T2, but T is greater than T1. Then F1 is F1K, F2 is F2S, A2, AR is 0. So, F2, we found out an expression for F2S where we got this intercept as well as. So, if I draw this correctly, this is 2. One will be So this is here. This is UNGM2. You are able to draw these figures perfectly once you are applying this. Now, they may ask, what is the time at which, what is the maximum time till which the system moves as a single entity? That means T2. You have to find out T2. At that instant, you say you are putting AR equal to 0, right? AR equal to 0 you can keep and find out F. F is nothing but KT2. So divide with K, you will get the answer. Have you understood this? Otherwise, you write that equation. First equation you write, I will show you, because this is a very, very important concept, my dear friends. F minus F1K minus F2K is M1A1 and M2A1 minus F2K is M2A. These are the most important relations. And if you get them, I think all that T is equal to less than T1, T is equal to T1, T is equal to T. Suppose I want to get at T is equal to T1 from this. What do? F1 is F1L, F2 0, AR 0, A2 of course is not there, so we need not bother. A1 just 0, about to start. So this is 0, this is 0, the whole thing is 0, therefore F1K becomes F1L. Likewise, you can deduce and get the answer. That's the reason why first, whenever they give the problem, take as though whole thing is sleeping. The lower body slips, upper body slips with respect to lower body, and then find out. So F1 is equal to, well, this is nothing but KT1, that's how I got T1. I hope you got this one. The next one is T greater than T1 but less than T2. What do you get? Less than. Now, AR is 0 because no slipping. F1 is F1K. F2 is F2S, static frictional force. And A1 is present. So, AR 0, this will go, this becomes F2S. F2S is equal to M2A1 and A1 you can get from this. So we already did that before. We got the slope which is less than K. So therefore this is slightly more bending towards x-axis, time axis. Sometimes they'll give friction here, they'll give time here. Be careful. Okay? I can draw that also for you. Yes, I'll do that. I'll do that. So this is fine. So you can do it. Now, at T is equal to T2. AR just 0. So this will go, this becomes F2L, M2A1 is F2L, mu2N, so A1 mu2G. Then I can substitute in this. A1 is mu2G, F minus mu1, sigma m into G, M1 plus M2 into G, minus F2L, that is mu2 M2G, and this is M1 into, what is A1? Mu2G. So F is equal to mu1 plus mu2 m1 plus m2 into t. And this is equal to kt2. Therefore, all this should be divided by t. This time it starts. Till this time the whole system moves together. Now, supposing this is time. This is frictional force. This one. Okay? Then this one go like this. This 1, 1, 1, 1. Is it 2, 2 to 0? And here, slope, it should be no more. If f is like this, time is like this, likewise it will go. If you turn it, you will get this answer. I hope this is clear to you. Always be watchful, which is abscissa, which is ordinate, and then know how to work on this two-body system. After all, I have just taken one example and then discussed it at length. Okay? In my next lecture, I will try to do the other part.